Okay, so a couple of things to mention if you skipped the last video about repeating it on the other side. One thing we've just gone and done is renamed those IKs again and put them back in their IKs group. So because we recreated them, these essentially got deleted and remade as new IKs, so you need to rename them and put them back in the IK group. So in this lesson we're going to make these stretchy IKs. So at the moment, as we move this out, the IK is going to stay behind because obviously that's the maximum length for this arm. But we want to be able to, because this is sort of like a, I feel bad because we haven't really seen the character that much, we've just been looking at these bones, but if we look at the character again, he's a cartoony character. So he's unrealistically cartoony because he's a slug with a snail even with arms. So we want to get some squash and stretch in there. We want him to have some really stretchy limbs. So to do this, we'll just hide the mesh and we'll just sort of go over the way this will work. So if we go to the top view, I'll make sure I'll reset this control. So if we go to the top view, basically you can see this as a triangle, the arm, so I'll probably bend that a bit more to see, so you can see it more obviously. So it's basically a triangle, this arm, going from the arm to the elbow to the wrist and back again. So the first length of the triangle is the length of the arm bone, and then the forearm. And all we're going to do is the total of these two lengths should be the arm when it's fully flat, when it's stretched to its max. So all we're going to do is we're going to take this value of the length of the bone, the length of the arm, sorry, at full stretch, and divide that by itself, and that should equal 1. Because if this was 10 divided by 10, that'll equal 1. And that will equal the scale of these joints. So all these joints have a scale of 1. So what we actually want to do is measure a distance between the start of the arm and the wrist control. So for instance, if I scale this out to the max, so if I scale this to about twice the length of this arm, so the length of the arm is 10 divided by the length, so we can take the length of the between the arm and the wrist control, which in this case if it's double would be 20, divide it by the length of the arm, which is 10, and that would equal 2. And as we said, that equals the length of the joints. And if we scaled all these joints by 2, so if we selected them all individually and scale these by 2, we would get, so it's about 2, we would get the arm to stretch. So you can see this arm is matching where the wrist control is. So I'll just undo that because we don't want to scale these manually. And I'll just double check that they're all at 1. But that's essentially what it's doing. It's taking the value of the length of the arm when it's at full stretch, with no actual stretch rig on it. So if you extend your arm now to its full amount, that's the value we're going to be using. And it's going to divide the length between the arm and the wrist control and divide it by that original value, and then apply that to the joint scale. And we're going to assign that to a way that once it's below that value, we're going to set that to 1. So once we're below, so once the arm starts to compress here, that's always going to be set to 1. So it's going to be a normal arm length. And we're going to add in a control. So on the wrist control, we can set if we want the stretch to be on and off. Because there's some parts of the animation you might not want the arm to stretch, but the IK might just overreach slightly, but we don't want the arm to stretch. So we're going to add an attribute in there so we can switch it on and off. Okay, so to start with, and again this might be confusing the first time you do it, but after you've set it up a few times, you stopped, and as we set it up now, it might become more clear. So again, to start off with, we're going to bring up the hypershade, and I'm just going to double check, make sure everything's at 0, make sure this is at 0, and I'm just going to go ahead and create a few nodes. So I'm going to create a multiply divide, create that. I'm going to create a condition node, and I'll explain that in a minute. And I'll leave them there for a minute, and then what we're going to do is we're going to create a distance dimension tool to measure the distance between the arm and the wrist control. So if we just go to create, and under measurements tool there should be a distance tool, and all that a distance tool is, we can just click out anywhere and it creates two locators, and you can hit enter, and all it does is creates two locators and a tool that measures the distance between them. And again, if you're using expressions, you can do this through mail. You can query where these two objects are and then subtract them and find out the distance between them. But again, we're setting all this up all through nodes so it runs more smoothly. So all I'm going to do with this now is vert snap to the joints, and I know that the wrist is on the same pivot point, in the same position as each other, so I can just snap it to the joint. And what I'm going to do here is just select the wrist control, select the locator of that distance tool. Let's go constraint and point, and do the same over here. Select the arm, select the locator, and because the last tool was point constraint, I can just hit G to repeat last command. And we can see it's added them in here, and eventually what we're going to do is add these to the extra nodes to hide, because we don't really need to see these. But I'm just going to leave them out here for the moment so we can see them. Okay, so coming back to the graph here, I'm going to select this distance dimension tool and the locators, just go graph, add selected to graph. And if I double click on this distance dimension 1, we can see here it actually has a distance attribute, and as I move these locators about, that distance is going to increase. So it's just basically the distance, and we can use that as an output. So what I'll again do in here is select each of these joints that we're going to add, and we're not going to scale the wrist joint because that would be scaling the arm. We just want to select all the joints, so the arm, the two elbow joints and the forearm. Let's go graph, add selected to graph. I'll just arrange them in a way so I can tell the hierarchy of these. Okay, so we've got all the nodes in there, and what condition node does, so we can just double click and see what it does in the attribute editor. And basically it's got a first term, second term, an operation, and then three vector values, so x, y and z, or r, g and b, of colour true and colour false. And all it's going to do is it's going to compare the first term with the second term, and then use the operation to pick one of these values. So here we can see the first term is 0, second term is 0, operation is equal, so it's saying is the first term equal to the second term, and if it is, we use the true value. So because 0 is equal to 0, we use the true. And then if I put this to 5, 5 does not equal 0, so the output of this node would be the false values. So that's a way that it's switching between the true or the false values. So what we actually want to do in here, so we'll start connecting these nodes up. So I'm going to take this distance dimension tool, drag and drop, go to other, on the multiply divide, and I'm going to take the distance might be quite hard to find this at first. Okay, so it's quite hard to find at first because it's not there, just realised. So one thing I'm going to do is select all the nodes in the graph and just go graph selected. and I'm going to move them to the side so we can just separate it from all these constraints and stuff. And one thing I just want to notice is up here, those two locators are also connected to a distance dimension shape node. So I'm going to move those across here as well. I'll just remove these from the graph. So graph, remove selected from graph. Select these and just press F to frame. And I can see actually we had the wrong distance. So we had the distance dimension shape selected, which is in the outliner. We just wanted to graph that and select the distance dimension shape 1, which you can see here has those two connections in. So they look pretty much identical. So just make sure you've got the right one selected. I'll just reorder this graph again, so we can remove them if we want. Graph, remove selected from graph. And you can always check if you go to the distance dimension shape and right click in the bottom right hand corner, you can see we've got that distance attribute there. So it means we can work with that attribute. Let's reorder these, and what we're going to do is take the distance, middle mouse click, drag and drop onto the multiply divide node. I'm going to take the distance and put it into the input 2. Put that in there. And I'm going to hit Control D, duplicate this, leave this down. Middle mouse click, middle mouse drag and drop onto the multiply divide node. I'm going to take the output X into the input 1. Now the reason I'm making a second multiply divide node down here, which if I double click that, I'm just going to put the defaults to 1 at the moment. We're basically, as we scale later on, as we scale this rig up, so we want to have a scale attribute, so I could select this global control and I could scale him up and the whole rig scales with him. Now if we do that, if you think we're using this value of the full length of the arm as the basis for this stretchy arm rig, so if we scale the rig up, it's also going to scale the actual arm up. So the arm, the length of the arm when it's locked would actually increase as the rig increases. So I'm adding this multiply divide node down here so I can take the value of the full locked arm, which we'll input later on, and I can times it, multiply it by how much we've scaled the rig up. So for instance, if the full locked arm was 20 again, if I doubled the size of this rig, so if I scale it up by 2, the full arm would be 40, and that would be multiplied in here. So any values that we use for the stretchy rig, because it's all deriving from this value here which is connected to the scale of the rig, everything's going to evaluate as normal, so we can scale the rig and the squash and stretch still works as expected. Okay, so now what to do is bring up this condition node, and I'm going to drag and drop the distance dimension tool onto that condition node, go to other, and I'm going to bring the distance and put it into the first term, and I'm going to go less than or equal. So I'm going to say that if the first term is less than or equal to the total length of the arm, so we'll get that now. If I stretch the arm to the max, so a good way to do this is I want to find the point at which I want the arm to start scaling, and I'm going to do this just ever so slightly before it's at full lock. As you can see here, they're at full lock. We can see that straight line going all the way through. I'm just going to add an ever so slight bend, so you can see there's a tiny little bit of a bend. I'm going to select that distance dimension tool, and I can see that that's 18.696, so it might be a different value on your end, but I'm just going to copy that value and you copy yours. I'm going to paste that into the second term, and I'm also going to do that in this multiply divide node. I'm going to paste it into the top value, and I'm just going to lock that so I know later on I don't need to change this value. Okay, so now we've got that going on, and first term, so it's going to check, is the first term less than or equal to the full lock of the arm? Set this back to 0, and again what we want to do here, we said the second term is the full lock of the arm, and because the full lock of the arm, the length of the arm, is going to change as the rig scales, we actually want to use this multiply divide node down here for the second term. So if I drag and drop this into the condition node, go to other, take the output x and put it into the second term. So what this means is, here we've got the multiply divide node, it's timesing the length of the arm by 1, which later on we're going to replace with the scale of the rig. So if the rig is at scale 1, we haven't scaled the rig, which means the full lock of the arm is going to be that distance that we've just measured now. If we double the rig to 2, it's actually going to double this whole arm rig. So we want to take that 18.696 times it by 2, because that's a new length of the arm, and then that's going to go up into the second term. So the second term is consistently always going to be the length of the arm, no matter how big or small we scale this rig. It's going to keep it in proportion, it's going to keep it the same. If we just left this as 18.696, if we scale the rig up, the length of the arm would change, and if this didn't update, the rest of this graph wouldn't work correctly. The arm wouldn't scale correctly, or wouldn't squash and stretch correctly. So we've got that going on, and now basically all we want to do is say, if the first term, which is the distance tool, so if the first term is less than or equal to the length of the arm, which means if the distance is here when the arm's pretty much stretched, or below, so when the arm's bent, we want to use a scale of true, which will be 1. So this means any time the arm is below the length of the arm, so any time this distance is less than the length of the arm, which basically means if the arm is bent like this, or slightly bent like this, it means we are going to use a scale of 1, which means no stretching. So this means as the arm bends, we don't want any stretching, which is what we want. We want the arm to bend normally and be at the normal scale. But here you can see if this is above, so if we go above, so here you can see the first term, if the first term is less than or equal to 18, which it isn't, we're going to use the false value. So this false value is going to be what we've chosen here, which is going to be the length of the arm divided by the original length of the arm. So actually what we want to do is reverse these. So here we've got the distance, so I'll just delete these two. So actually we've got the distance going into x, so the multiply divide input x, 2x. So I'll just delete these. We'll redo that, I did it the wrong way around. So we'll take the distance and put it into the input 1x. We'll select the global scale, reload that, and put that into the input. So take the output x, put that into the input 2x, hit close. And so here what we're doing is we're taking the length of the arm, which is considerably larger than the arm because we've moved it out. Well, it's not considerably, but we can move it a bit more if we want. So I'm going to move it approximately twice the length of the arm. And then what we're going to do is take this value, divide it by the original length of the arm. Because it's bigger, we're probably going to get, so we'll round this up, this is about 20, about 50, so it's going to be over twice the length of the arm that we want to scale it. So we're going to take this value, the output x, and put it to the colour if true. So we're going to minimize click, drag and drop over, take the output X, and we're just going to put colour if false, and just put in the R, G and B. And we don't really need to put it in all three, but I'm just putting it in there. Hit close. So this means, as you can see, so what I'm going to do here is select the condition node, go to list auto load selected attributes, and by unchecking this means no matter what I select, this isn't going to go away from that condition node we selected. So as you can see, if I reset this back to 0, this arm, you can see 80, first term is less than or equal to that, so it's going to choose 1. So he's going to scale 1. If this goes above, so if this goes to, so here you can see first term is 40, it's higher, so it's higher than the length of the arm, so it's going to choose the false value, which is 2. Because this is about, so if we say about here, this is twice the length of the arm. So you can see now it's going to use a 2 value for the scale. So if we scale all these joints by 2, these joints would match with that wrist. So it will be scaling the arm as normal, as we'd expect it to be a stretchy arm. So we're going to go ahead down here, and one thing I'm going to do is add a blend colour. And like what we said earlier, we would like the ability to switch this stretch on and off. So adding the blend colour again, if I just select this wrist control and go to edit, add attribute, we're going to add stretch, and on this stretch we're going to add a minimum of 0, maximum of 1, default 0. Just click add, and usually I keep these at 0s and 1s because you're not really going to be wanting to blend it that much, the squash and stretch. You usually just want to turn it on or off, and by keeping it at 1, that means I can usually use that 1 value to drive things like the visibility of objects. So the IKFK switch, we kept that to 0 of 1, and we could use that 1 to drive the visibility of objects, because the visibility is either 0 or 1, or the weights of orient constraints are 0 or 1. If I'd set this to 10, I'd then have to set up everything as set driven keys. So I just prefer, if I can, keeping this as 0 to 1, so I can use that direct connection. But you can keep this as 10 if you want, or 100 for 100%. It's up to you, but I'm just going to keep this as 0 or 1. So just click add. We've added that stretched attribute. I'm just going to go to graph, add selected to graph again to get that control in there, and I'll drag and drop this onto the blend colour, go to over, select the stretch onto the blender. So this basically means when this stretch is a value of 1, we will be using the true values, and then a value of 0, we will be using the second values. So basically what I'm going to say is, when it's at 1, I want to use the R, G and B up here, which we're going to connect to the stretch network. If it's 0, I want to use these 3 values here. And I don't want these as 0, because these are going to be scale, and the default scale is 1, so I'm going to switch that to 1. Now what I can do is drag and drop the condition onto blend colour, go to other, take the out colour and put it into the in colour, and I'm just going to connect all 3. You don't really need to, but I'm just connecting all 3 so we can use these later on if we want, but probably won't, because we're only going to be scaling the actual X, we're not scaling the X, Y and Z. And then what I can do here is take the blend colour, drag and drop onto each one of these joints, and before I connect this up I just want to double check that if we select the scale tool and press down to go down the hierarchy, you can see that scale X is pointing down every single axis. So the scale X is what we want to scale with, and that's why earlier on setting up the orientations of these joints, that's why it was so important, because if these orientations were off and there wasn't an axis aiming down the bone, we wouldn't be able to set up this squash and stretch. It will be pretty much impossible. So keeping that axis aiming down the joints allows us to just easily set up this stretch control now. So I'm just going to take the output R, put this into the scale X, and because the blender's set to 1, we should be able to start to see this arm stretching into place. So select the next joint, reload right, input it to scale X, select the next joint, reload right, input it into the scale X, and then the last joint, forearm joint, reload right, put that into the scale, not the rotate one, on the scale X. Have I done all these joints? Scale X. I missed the last joint, so taking the out R, scale X. So I got a bit worried there, but we just missed that last joint there. And I'll close that. So now we can see, as I move this arm about, we're getting that nice scaling going on. And as we go below, it switches off. So because the condition around here, the arm is less than that condition, it's going to switch to that colour true. So on that condition node, it's going to switch to the colour true value, which is 1. So all these scales are going to be 1 if we select these. So you can see here how that's going to switch on and off. And then the stretch attribute, you can see here, selecting the stretch, middle mouse clicking the viewport, you can see that now we can switch that scale on and off. So this is controlling the blend color, which is switching between the graph of the squash and stretch that we set up earlier with the condition nodes, and then switching between a value of 1, which is no stretch. So you can see here how quickly we can just set up a squash and stretch, and how in hindsight I know that we want the scale of this rig to be connected to the scale of the arms. So I've added in that multiply divide node at the start of the graph, so later on when I add in the scale attribute, when we scale up this rig, it's also going to scale the value of the arms, so the squash and stretch for the arms will still work. We're not going to get any weird results. Okay, so that's just a quick tutorial for setting up the squash and stretch for the arm. And later on, so we'll be doing this later on when we start to go into probably facial rigging, when we start to explain blend shapes. But an added bonus later on, what we're going to do is, as we increase the length of this arm, so as the arm stretches, we can have, so when this is skinned later on, the arm will follow, but the arm will stay the same volume, the same thickness, so it'll just be a tube that's scaling up. But later on what we're going to do is connect a blend shape to this scale attribute, to this squash and stretch rig. So as we stretch the arm's going to follow, but it's also going to become really thin, which appears like it's keeping the volume. So if you stretched a piece of blue tack, for instance, it stays quite thick, but as you stretch it, it gets really thin in the middle. So to keep the realism, and also to make it look more cartoony, like he's really stretching his arms, as he stretches his arms, we're going to make his arms go really thin, so it looks like that squash and stretch is working even more. Okay, so that's the way to set up the squash and stretch. So in the next tutorial, again, I'm just going to be doing this on the opposite side, so feel free to skip that again if you don't want to follow it through again, if you're happy with setting up yourself. If you're quite new, I recommend going through this again, so if any problems happen we can sort them on the spot. So feel free to skip the next video, but if not, we'll just be setting up the squash and stretch on the opposite arm.